Good morning, dear students. My name is Ferhan Mazher, and the subject today we are studying is Cambridge IGCSE Physics. This is extended physics. The code of the subject is 0625, and the paper we have selected to solve today is May-June 2023 2-1 paper. This paper 2 belongs from the Zone 1. In this paper, the mode of the question is multiple choice questions. There are 40 questions, and the time allowed for this paper is 45 minutes. In this video, I'm going to present you the solution of this paper to the best of my abilities and to the best of my knowledge. So let's start today's paper. Okay, so here we go. Okay, so we are on the May-June 2023 210625 is the code of the subject. So let's start. Here we go. Question number 1 is showing up on your screen. He says the vector question number 1, which vector diagram correctly shows the force Z as the resultant of forces X and Y? You see these two forces, X and Y, we want to find out their resultant, and their tails are joined. When you join the tails of the two vectors, we use parallelogram law. So this is not the parallelogram law. Here again, the tails of the two vectors to be added is joined, so we are supposed to use the parallelogram law. So we cannot use the triangular law here. Here, the head of the first vector is joined with the tail of the second vector, and the resultant is, this is right situation for the triangular law. You put the tail of the second vector at the head of the first vector, and the resultant is you join the tail of the first vector with the head of the last vector. But here they have not done this. In this diagram, the D diagram, at the head of the first vector, they have put the tail of the second vector, and then they joined the tail of the first vector with the head of the last vector. So this is the right answer, sir. So I think D is the answer. Question number 1, D is the answer, which is right. Question number 2. He says, question number 2, an object falls towards the surface of the earth. The object is falling at its terminal velocity. Which statement is correct? There is air resistance and the acceleration of the object is negative. And because you are falling with the terminal velocity, when you fall with the terminal velocity, your velocity becomes constant. When your velocity is constant, that means the acceleration is 0. So there is air resistance and the acceleration of the object is 0. This B statement looks right to me. Okay, there is no air resistance, there is air resistance. There is no air resistance, there is air resistance, because you are falling towards the surface of the earth. So I think B is the right answer, sir. Question number 2, B is the right answer. Question number 3, the graph represents the motion of a vehicle. What is the distance traveled by the vehicle in 400 seconds? You see, it's a speed time graph, and the area under the speed time graph is equals to the distance traveled. So the area under the speed time graph is in the shape of a triangle. So I am going to find out this area. So this is a shape of a triangle. So the area of the triangle is 1/2 into base into the height. Okay, so I can find this area. So let me show you. I have done this. The area of this will be distance travel is equals to the area under the speed time graph, and 1/2 base into height. The 1/2, the base is 400 and the height is 20. So 1/2 into 420, and that is 4,000 meters. So 4,000 meter. 4,000 meter is the right answer, sir. So 4,000 meter is the right answer. So I think C is the answer. Question number 3, C is the right answer. Okay, now we are going to the next question. That is question number 4. He says, on the earth, a spring stretches by 5 centimeters when a mass of 3 kg is suspended from one end. The gravitational field strength on the moon is 1/6 that on the Earth. Which mass on the moon would stretch the spring by the same extension? To produce the same extension, whether you are on moon or you are on Earth, you need same amount of the force with which you will stretch. Okay, so on Earth, the mass is 3 kg. So we know the G value on the Earth, that is 9.8 Newton per kg. So I will find out how much is the weight of the object. Same weight must be on the moon. So then I will find how much mass is needed there. So let me show you this solution. Okay. On Earth, the weight of the body is W is equals to mg. The mass is 3 kg. The G value on the Earth is 9.8 Newton per kg. So it will be 29.4 Newton. So this much force is needed to produce an extension of 5 centimeter. So on the moon, if you want to, the G value on the moon is 1/6 of the G value on the Earth. So 1/6 of the 9.8, that will be 1.63 Newton per kg. So for the same extension, same force is needed. So the weight on the moon must be equal to the weight on the Earth. The weight on the Earth, we know, which produced that extension, is 29.4 Newton. So the weight on the moon must be same. So the mass of that object which can produce this much weight, which have this much weight, I mean, the G value on the moon is 1.633. So the M will be equals to 29.4 divided by 1.633, that is 18 kg. So to produce the same extension, 18 kg body will be needed on the moon. So I think D is the answer. This is question number 4. Let's check first of all. D is the right answer, sir. This is the solution. Let me reduce the size so you can see the whole part. Okay. I hope you can see this whole thing together. Now, this is the solution of that question number 4. So we are on the question number 5. He says, a shopkeeper pours rice into a dish that hangs from a spring balance. He records the reading. A customer buys some pasta. The shopkeeper notices that the reading on the spring balance with just pasta in the dish is the same as it was with just rice in the dish. Which quantity must be the same for the rice and for the pasta? So the options here are density, no; temperature, no; volume, no. This measures the weight, and if the reading is for the rice and for pasta is same, that means both of them have the same weight. Both of them have the same weight. So I think D is the option for question number 5. We think D is the option for question number 5. D is the right option, sir. So let me reduce the size so you can see the whole question together. So this is question number 5, and its right option is D. Okay, so we are going to the next question, and the next question coming up on your screen is question number 6. Okay, he says, a student determines the density of an irregularly shaped stone. The stone is slowly lowered into a measuring cylinder, partly filled with water. Which other apparatus does the student need to calculate the density of the irregularly shaped stone? You need to find the density of an object. You need mass and you need volume. So from the measuring cylinder, we are going to find out the volume, and for mass, you need some electronic balance or balance. Okay, which other apparatus does the student need to calculate the density? We need a balance to measure the mass. Okay. So I think A is the option, sir. Question number 6, A is the right option. Question number 7. A train is traveling horizontally in a straight line. A book is on a table in the train. The diagram shows all the forces acting on the book. How is the train moving? You see, upward force, downward force, they are balanced with each other. The weight is acting downward, the reaction of the table is acting upward. Now, because this table, the table is basically not moving, the train is moving, we think, and you know, the book, the friction between the book and the table is towards the right. So that means that the friction is always opposite to the direction of the motion. That means that the train is basically, the train is moving. This is the direction of the train in which the train is moving. Okay. So the train is going to the right. So try to understand this story. The train is going to the right. Okay. But the, due to the inertia, the book will try to go backward due to the inertia. This is happening due to inertia. Okay. Now, because of the, due to the inertia of the book will try to go backward because the train is going in this word. So there is friction between the book and the table towards the right. So that means the train is going towards the right. And we believe that there is acceleration. That's why there is the friction, resultant friction force towards the right. So I think B is the right answer, accelerating to the right of the accelerating to the right of the diagram. So question number 7, B part, very tricky question, not an easy one. It's a very, very tricky part. So this is question number 7, it's B part. It's not easy. Okay, now we are going to the next part, that is question number 8. He says, the diagram shows 4 beams, each of negligible weight and freely pivoted. Which beam is not in equilibrium? Okay, so that beam will be in equilibrium, in which the clockwise moment and the anti-clockwise moment, they will be equal to each other. So here we know the force, we know the momentum, we know the force, we know the momentum. This will produce a clockwise moment, this will produce an anti-clockwise moment. Same is the case everywhere. Here we have two forces on this right side. They both are producing a clockwise moment. So their sum will be equals to the anti-clockwise moment. So we will see in which they are equal, clockwise and anti-clockwise. And if they are equal, then that thing will be in equilibrium. But if they are not equal, the clockwise moment and the anti-clockwise moment, then what will happen? They are not in balance. I mean, that body is not in equilibrium. We are looking for that body. Let me show you my calculation. So here we have, okay. So for the body A, the clockwise moment is equal to the anti-clockwise moment. So 6 multiply 1, and that is 6 Newton meter, and 3 multiply 2, that is 6 Newton meter. So this body is in equilibrium. For the body B, the clockwise moment is equal to the anti-clockwise moment. We are checking this. Okay, 6 multiply 2, that is 12 Newton meter, and 6 into 2, that is 12 Newton meter. So this body is also in equilibrium. For the part C, the clockwise moment is equal to the anti-clockwise moment. Let's see, 3 multiply 2 and 3 multiply 1. This is 6 Newton meter, the clockwise moment, and the anti-clockwise moment is 3 Newton meter. So they are not equal to each other. So that means that this body is not in equilibrium. So the body C is basically not in equilibrium. If you check the body D, the clockwise moment, there are two forces which are producing clockwise moment. So 4 into 1 plus 2 into 2. So their moment is 8 Newton meter, and the anti-clockwise moment is only one force there, 4 into 2, and that is 8 Newton meter. So this D force is also in equilibrium. Only the C1, the C option, they are not in equilibrium. So I think C is the answer, sir. So let's check question number 8. It's a C part. Question number 8, it's a C part. Okay. Now we are going to start from question number 9. An object of mass 1.2 kg is moving with a velocity of 2 meters per second when it is acted on by a force of 4 Newton. The velocity of the object increases to 5 meters per second in the same direction. For which period of time does the force acts on the object? Okay, so we know the force which acted there, and we know the initial velocity, we know the final velocity, we know the mass of the body, and we want to find out the time period. You know, the impulse is equals to force multiply time, and impulse is equals to change in momentum. F force multiply time is equals to change in momentum. So we will apply that formula, and from there I can calculate the time. Okay, so here we have so mass is 1.2 kg. The initial velocity is 2 meter per second. The final velocity is 5 meter per second. And the force is question, that is for a Newton. Time is question. Impulse is equal to change in the momentum. Impulse has two formulae. One is force into time. Another one is change in the momentum. So 4 multiplied t equals to 1.2 multiply 5 minus 1.2 into 2. And 4t will be equals to 6 minus 2.4. So 4t will be equals to 3.6. So t will be equals to 3.6 divided by 4, and that will be 0.9 seconds. So it will take 0.9 seconds. So I think A is the option. Question number 9. A is the right option, sir. So A is the right option. So this is how we have solved it. I hope you understand impulse, both the formulae of the impulse. Okay, next question. Question number 10 on your screen. He says, which row about the change of energy in the energy store must be correct? Process. Water pumped up to a high altitude dam. Energy store. Gravitational potential energy of the water change energy in the store increases. So when you pump water up to a high altitude, obviously the gravitational potential energy will increase. B option is water pumped up to a high altitude dam. Kinetic energy of the water decreases. We are doing this with the help of the pump. Do the velocity of the water decreases? I'm not sure. Okay, so air, because when the speed of the water will decrease, then the kinetic energy will decrease. C is air passes through a wind turbine. Gravitational energy of the air increases. That is not right. Air passes through a wind turbine. Kinetic energy of the air increases. That is also not right. Because you see, the kinetic energy depends upon the speed. If the speed increases, then the kinetic energy increases. Okay, so the most good answer to me is looks the water pumped up to a high altitude dam where you take the water up. So obviously the gravitational potential energy of that water will increase. To me, it looks that A is the perfect answer. So let's see. Question number 10, A is the right answer, sir. This has some doubts in it. Because kinetic energy depends upon the speed. We are not sure about the speed. Okay, question number 11. A woman of mass 50 kg has 81 joule of kinetic energy. What is her speed? You know the kinetic energy is 1 by 2 mv square. We know the kinetic energy. We know the mass of that woman, and we can find its velocity. Okay, so kinetic energy, you know, is equal to 1 by 2 mv square. So 81 is equal to 1 by 2 into 50 into v square. So v square will be equal to 2 multiply 81 divided by 50. So v square equals to 3.24, and v will be equal to 1.8 meter per second. 1.8 meter per second. 1.8 meter per second. So I think C is the option. Question number 11, C is the right option, sir. And this is how we have done that. Question number 12 on your screen. A child runs up a set of stairs 4 times. The time taken for each run is recorded, which time is measured when the child's useful power is greatest. You know, the power is equal to the work done divided by the time. If you go 4 times on the same stairs, all the 4 times the work done is same. Okay, going to a certain height with the help of a stair, same stair, I mean, you do it 4 times, every time the work done is same. But if you do the work in less time, the power will be more. So we are looking for the greatest power. The greatest power is when he run up stairs quickest in least time. So where's the least time? Here, A option. When he took least time to run up those stairs, that is when he has the greatest power. So I think question number 12A is the answer, which is right, sir. Question number 13. It says, a dam holds water in a reservoir. The height of the water in the reservoir is 15 a meter. The density of the water is 1000 kg per meter cube. What is the pressure due to water at the bottom of the dam? Okay, at the bottom of the dam, I means here they are talking about here. Okay, the height of the water above the point of observation, that is 15 meter. You know the pressure is equals to rho gh. Rho gh. We are looking for the pressure due to the water. So rho gh is the formula. Okay. So question number 13, pressure will be equals to rho gh. So the rho density is 1000 and the g value is 9.8 and the h means the depth of the water above the point of observation. That is 15 meters. So when you multiply them, you get 147,000 Pascal. When you round it off, it is 150,000 Pascal. 150,000 Pascal. 150,000 Pascal. I think, sir, D is the right answer. Question number 13, D is the right answer, sir. And this is how this is solved. Okay, so we are going to the next question. That is question number 14. A student uses a microscope to observe pollen moving on the surface of water. Which statement describes the reason for this movement? You see the pollens in the water, they do the random motion, and that random motion is basically because those pollens are bombarded with the molecules of the water, and they are basically showing the movement of the particles or molecules of the water. So water molecules are moved by microscopic pollen particles. No, the pollen particles are moved by the water molecules. Water molecules are moved by the pollen particles. No. Microscopic pollen particles are moved by the water molecules. Yes, that is true. And pollen molecules are moved by the water molecules. So I think these C and D, they look good, but here is a difference. Pollen does not have, I mean, pollen particles, I don't know. Microscopic word is right. I think C is the option. Question number 14, C is the right option. You see, these two statements are kind of same. Only difference is between the microscopic and just the pollen molecules. Okay? Pollen particles. Okay. Question number 14, C is the answer. Yeah, that's right. Question number 15. He says, which statement about evaporation of water are correct? Evaporation causes the remaining liquid to cool. That is true. During evaporation, the more energetic particles escape from the surface of the liquid. That is true. Evaporation only happens at 100 degrees centigrade. That is wrong. So only 1 and 2 is right. So I think B is the option. Question number 15, you can see 15, B is the right option. Question number 15, B is the right option, sir. Question number 16, he says some hot water is sealed inside a metal can. So now the volume cannot change. The can is in a vacuum in outer space. The hot water slowly cools down. How does the thermal energy escape into the space? You see, in the space, there is no medium to escape there. Therefore, the heat only process is by the radiation, infrared rays. But heat will come out from inside the hot water, which is inside the can, to the outside of the can by the process of conduction. So first the conduction will happen. By the conduction, the heat will come from the water to the outer surface of the can, and from there it will spread into that space by the process of radiation. So I think B is the answer. Question number 16. B is the right answer, sir. Question number 17. He says the diagram shows graphs of displacement against time for 4 waves. All the graphs are drawn to the same scale. Which wave has the largest amplitude and the highest frequency? Largest amplitude means from the mean position how high you go. For example, this is going 2, this is also going 2, and these are going only 1 up from the mean position. So the highest amplitude is either in A or B. And then he says highest frequency. Higher frequency is that waves which on the same display shows more number of waves. So I think A is the option, because in the same space, more number of waves are shown. It has the largest amplitude, but the number of waves on the display are less. So its frequency is less. We are looking for the highest frequency. Highest frequency is there where more number of waves in that time. So I think A is the option. Question number 17, A is the right option, sir. Question number 18. The diagram shows a ray of light entering a glass block. Which calculation gives the refractive index of the glass? Okay. So this is the angle of incidence in the rare medium. And this angle of incidence is how much? This will be how much? It will be 90 minus 50. It will be 40. So the refractive index will be sine I divided by sine R. That is sine 40 divided by the sine 25. Here the angle of refraction is 25. The angle of incidence is 40 degree. Angle of refraction is 25. So the refractive index N is equals to sine I by sine R. So it will be sine 40 divided by the sine 25. So I think A is the answer. Question number 19. He says, okay, an object O is placed at the point P near to a thin converging lens. The diagram shows 3 rays from the top of the O passing through the lens. Each point F is 1 focal length of the center of the lens. From the center of the lens, each point 2F is 2 focal lengths from the center of the lens. The object O is moving to the point Q on the diagram. Which type of image is produced when the object O is at Q? Inverted? Yes, obviously the image formed will be real. It will be inverted and its size will become larger. It will be magnified. Inverted and the same size as the object? No. Inverted and enlarged? Yes. When you are between 2F and F, the image formed by the convex lens is real, it is inverted, it is enlarged. C and D are wrong. The image is not upright, the image is inverted. So I think question number 19, B is the answer. Yeah. He says, okay, question number 20. Which diagram shows the dispersion of the white light by a glass prism? Okay, when the white light will pass through the glass prism, the light will spread into its colors. That is called dispersion of the light. And but the important thing is when the light enters into the prism, at that very point, the light split into color. And the order of those color is red, orange, Roy G. Biff, you remember that? So red and violet. So this is not right. Why? Because here the colors have not split it. This is right. This looks good. Uh, you see, when after coming out, emerging from the prism, the both the rays are parallel to each other, which is not right. Same problem with the here, the rays are parallel. And this ray, when entered into the air, has not changed its path. That's why it's wrong. To me, B looks the best. Question number 20. Let's see what is the answer. So this is how you do this question. So question number. So we are on question number 21. He says visible light has wavelengths in the range 4 expo minus 7 meter to 7 expo minus 7 meter. What is the range of frequencies of the visible light? We know the speed of the visible light. So I will find the frequency for each wavelength. And let me show you the calculation. Okay. You know that V is equals to F lambda, the speed of the the speed of the light. The speed of the light is 3 expo 8 meter per second, and the wavelength. There are two wavelengths basically given. One is 4 expo minus 7 meter. So I will find the frequency for that when I divide 3 expo 8 meter per second with the 4 expo 5 uh, 4 expo minus 7 meter. I get 7.5 expo 14 hertz. And then I will calculate the other frequency. V F is equals to V by lambda. The V is 3 expo 8 meter per second, and the lambda is 7 expo minus 7 meter. The answer will be 4.3 expo 14 hertz. So the range is 4.3 expo 14 hertz to 7.5 expo 14 hertz. 4.3 to 7.5. It was raised to power 14. Yeah, raised to power 14. So D is the answer. Question number 21, D is the answer. Okay, so we are going to the next question. That is question number 22. He says student X fires a starting pistol which produces smoke and sound. Student Y is standing 100 meters away and sees the smoke the instant it is produced. The speed of the sound in air is 340 meters per second. What is the time delay between the student seeing the smoke and hearing the sound? We know the speed of the sound. We know the distance the sound has to travel. So we can tell how much is the time for this. So let me show you. So speed is equals to distance divided by time. So time will be equals to distance divided by speed. So the time will be equals to 100 meter divided by 340 meter per second. And the answer is 0.294 seconds, 0.29 seconds, 0.29 a second. So A is the answer, sir. Question number 22, A is the answer. Right answer, sir. Our answer is right. Question number 22, A is the answer. The next question coming up on your screen is question number 23. He says, an unmagnetized piece of soft iron is placed close to a strong permanent magnet as shown. What is the induced polarity of the end X of the soft iron, and in which direction does the magnetic force act on the soft iron? So when you put a soft iron near this end, this end will automatically become south and this end will become north. So they will be attracted. So the force will be in this direction. There will be attraction. So polarity of the end X will be south and direction of the force on the soft iron will be to the left. So I think C is the right answer, sir. Let's check question number 23. C is the right answer. Okay, so we are going to the next question. That is question number 24. A plastic rod is rubbed with a cloth. Okay, so both are insulators, so you are rubbing them together. The rod and the cloth both become charged as electrons move between them. The rod becomes negatively charged. Okay, the rod becomes negatively charged. That means the electrons have moved from the cloth to the rod. That's why the rod has become negatively charged and the cloth will become positively charged. Which diagram shows how the rod becomes negatively charged and show the final charge on the cloth? If the rod will become negatively charged, the cloth will become positive charge and the electrons will move from the cloth to the rod. So I think B is the right answer, sir. So let's check question number 24. B is the right answer. This is question number 24. And let me reduce the size. Yeah. Question number 24, I think B is the right answer. Question number 24, B is the right answer. I hope you understand the electrons have moved from the cloth to the rod. That's why the rod has become negatively charged. So now we are on question number 25. He says a wire has a uniform circular cross-sectional area. Which statement is correct? The resistance of the wire is directly proportional to its cross-sectional area and inversely proportional to its diameter. No, the resistance is inversely proportional to the cross-sectional area. The resistance of the wire is directly proportional to its cross-section. That is wrong. A and B both are wrong. The C part is the resistance of the wire is directly proportional to its length. That is true. And inversely proportional to its cross-sectional area. That this sentence is 100% correct. The resistance of the wire is directly proportional to its length and inversely proportional to its diameter. It's not inversely proportional to its diameter. It's inversely proportional to its cross-sectional area. Very important sentence. C is the right answer, sir. Question number 25, C is the right answer. Question number, then we have 26. He says, the diagram shows the current voltage graph for a metal wire. What can be deduced from the graph? As voltage increases, the temperature of the wire increases. You know, this graph is a graph which is obeying Ohm's law. The current and the voltage, they are directly proportional to each other. In this, the temperature and the resistance of the conductor do not change. So as the voltage increases, the resistance of the wire increases. No. As the voltage increases, the resistance of the wire remains constant. That is the right thing, sir. You know, the gradient here, that is equals to 1 by R. Because the gradient is constant, so from here we suppose that the resistance is also constant. So voltage is increasing, but the resistance remains same. Question number 26, D is the answer. This is a perfect diagram, a graph, IV graph for the ohmic conductor. Question number 27. A battery is connected to a circuit. It is switched on for 1 minute. During that time, there is a current of 0.40 ampere in the circuit, and the battery supplies a total of 48 joule of energy. Which row gives the charge that passes and the electromotive force EMF of the battery? You know, there are two calculations involved here. We know the time, we know the current. So you know the I is equals to Q by T. So from there, I can tell you the amount of the charge, that is Q charge divided by time. So from I know the current, that is 0.40 ampere. I know the time, that is 1 minute, which means 60 seconds. And I can calculate the charge. Okay, once I know the charge, then I can calculate the EMF. EMF is equals to the energy divided by the charge. an EMF. The formula for the EMF is EMF. The formula for the EMF is energy divided by the amount of the charge. Okay, so let me show you my calculation. Is I have shown this. Okay, so I is equals to Q by T. So Q is equals to I multiplied T. I is 0.40 ampere. The time is 1 minute, which means 60 seconds. So 0.40 multiplied 60, that is 24 coulomb. So that means that the charge is 24 coulomb. EMF is equals to the energy divided by the charge. Energy is 48 joules and the charge is 24 coulomb. So that is 2 volt. So the charge is 24 coulomb and the EMF is 2 volt. So I think C is the right answer, sir. Question number 27, C is the right answer. Question number 28 on your screen. The circuit diagram shows two identical lamps connected in parallel to cell. 3 ammeters X1, Y, X, Y, and Z are also connected in the circuit as shown. Which statement about the current in X is correct? You see the X is measuring the amount of current coming out of the battery. The current flowing through this first lamp is noted by the Y, and the current noted by the current which is passing through the second lamp, which is the second branch, that is Z. So X will be basically equals to the sum of the Y and the Z. Because the current has divided into two branches, okay? So the X will be equals to Y plus Z. It is equals to the sum of the current in the Y and the current in the Z. C is the right option, sir. So question number 28, C is the right answer, sir. I hope you understand this concept, which I just told you. This X is noting down how much is the current coming from the battery, and Y and Z, because the current divided into two branches. So Y plus Z will be equals to X. Okay, this is the basic concept there. Question number 29. He says the student connects the circuit shown. Okay, which switches must be closed for the battery to ring without lighting the lamp? Bell to ring without lighting the lamp. Okay, so close this switch. Okay, so close this one. Okay, and close the third one. So close the switch 1 and the 3 and the bell will ring, but the lamp will not without lighting the lamp. Okay, so 1 and 3. So I think B is the option, sir. Question number 29. Question number 29, B is the right answer, sir. Question number 30. The diagram shows C generator. We have here permanent magnets. Between those permanent magnets, we have a coil, then we have those slip rings, and each side of the coil is connected with a different slip ring. Then, okay, so this coil is rotating in which direction? It is rotating clockwise. Okay. Now he says the graph shows the potential difference between the point X and Y plotted against the time. A positive value of the potential difference indicates that X is more positive than Y. Okay. Now, here you see, here we have that graph. Which diagram shows the position of the coil at the point P on the graph? At the point P, you see the X is negative. Okay. The X will be more negative than the Y. Okay. Now, if I apply the right-hand rule for the AC generator, if you look at the diagram C, I'm working on the diagram C, the magnetic field is going in this direction. This is the direction for the magnetic field. If you pay attention to this side, This side, because the body is moving, this is body is moving um, clockwise. So this side of the coil is going downward. And this side of the coil is going basically upward. Okay. So, for example, when I apply the the right hand rule on suppose this side, this one. Okay. So this is my right hand. I don't know if in this diagram it's clear. This is my right hand. So I will strike the three fingers of this right hand mutually perpendicular to each other. So this is FMC. This is the force in which direction the coil is moving, and this is the magnetic field. This will be the conventional current. Okay. So uh, this side is basically going downward. So the force is downward. The magnetic field is towards the right. So I have to bend my hand, and the this is the force. The body is going downward. Then this finger which is pointing towards me. So the conventional current will be towards this side. So that means the current will be coming here through this slip ring. And we're talking about conventional current. Okay, this law is all about conventional current. It will come out. So Y will be more positive, then X will be negative. Okay, this will be this is the force, motion, I mean, force. So the direction of the conventional current, this is a very, very tricky question. The direction of the conventional current will be this. This is the direction of the conventional current. So we are talking about conventional current. So through this slip ring, the conventional current will come higher. This will be more positive. This will be more negative. We are looking for the point P. At the point P, the X is negative. Okay. So C is the answer. It's a very, very conceptual question. Not easy. It's not easy to answer this. Question number 30, the C is the right answer, sir. Question number 30C is the right answer, but this question is not easy. We have to use the right-hand rule for the AC generator, and the right-hand rule is about the conventional current. We found the direction of the current. From there, we know that the current is coming from the Y and it's going to X, and talking about the conventional current. That means the X is negative. From there, I know it's C. It can be A also, but it's not A, it's C. Why? Because after applying the right hand rule, we are able to tell this. So it's a tricky question. Oh my God. Okay, so we are going to the next question. That is question number 31. An electron moves into a uniform magnetic field. The arrow shows the initial direction of motion of electron. The direction of magnetic field is into the plane of the page. In which direction does a force on the electron when it enters the magnetic field? Okay, so we are going to apply the left hand rule, Fleming's left hand rule. Okay, so stretch the fingers mutually perpendicular to each other, and this is thumb, this is the index finger, this is the index finger, this is the middle finger. FMC, force, magnetic field, and current. So this is electron, and but this law is about the conventional current. It's not about the electron. So let's apply this. The charged particles are going in this direction. Magnetic field is into the page, and my thumb is pointing upward. That means this should go upward, but this law is not about the negative charges. This is about the positive charges. But this is electron, which is negative. So it will bend opposite. So it will bend towards the bottom of the page. So I think C is the answer, sir. Question number 31, C is the answer. Okay, so we are going to the next question, and that is question number 32. He says, which statement about a transformer is correct? You know, the transformer is used to change the voltage or change the current. There is an alternating current in the iron core for the primary coil to the secondary coil. No, in the core there is no current. In the iron core there is no current. The current is in the primary coil, the current is in the secondary coil. An alternating current in the iron core induces an alternating current in the secondary coil. No, in the iron core there is no current. An alternating current in the primary coil induces a direct current in the secondary coil. That is true. In the primary coil we connect all alternating current, and in the secondary coil automatically alternating current is produced. Oh, sorry, he said direct current. In the secondary, direct current is not induced. In the secondary also the alternating current is induced. So the right choice will be an alternating current in the primary coil induces an alternating voltage across the secondary coil. Sorry, this is the answer, sir. D. D is the answer, sir. Not direct current. The alternating current is induced in the secondary coil. An alternating current in the primary coil induces an alternating voltage across the secondary coil. So D is the right option. Question number 32, D is the right option. You see, they are so confusing sentences. They can confuse you very easily. Okay, question number 33. How are the positive and negative ions formed from atoms? Okay, how are positive and negative ions formed from an atom? If an atom will lose electrons, it will become positive ion. And if it gains electron, it becomes a negative ion. Add positive charge. No, this is not possible. Add positive charge. This is not possible. Remove an electron from the atom. Yes, then it will become positively charged. Add an electron to the atom. Yes, that is true. So I think C is the best answer, sir. Remove an electron from the atom and it will become positive ion. Add an electron to the atom, it will become negative ion. C looks the best option to me. Question number 33. C is the right option. Okay, sir. Now we are going to question number 34. He says the nucleus of element X is represented by X2656, which is an isotope of the element. Isotopes will have the same number of protons, so their proton number will be same. So I think clearly the B is the option. Question number 34, B is the right option. They will have the same number of protons in them. Question number 35, he says a radioactive source is placed near a detector connected to a counter. 210 counts are recorded by the counter in 3 minutes. The background count rate is 20 counts per minute CPM. What is the corrected count rate for the radioactive source? It will be, I think, from 210 you have to it says a radioactive source is placed near a detector connected to a counter. 210 counts are recorded by the counter in 3 minutes. The background count rate is 20 counts per minute. What is the corrected amount? I think corrected amount will be, let me show you the solution. I have done this. So in 3 minutes, the total count which we have got is 210. So what is the count in 1 minute? That will be 210 divided by 3. That is 70 pounds per minute. So it will be, so in 1 minute, your total counts you are getting is 70. So from that, subtract the background. So 70 minus 20, and that will be 50. So the actual count rate is 50 counts per minute. 50 CPM. A is the option. You see, let's first check 35. A is the option. This is how you have done this. Question number 35. Okay. Question number 36. A background count rate measured by a radiation counter is 40 counts per minute. With the counter close to a radioactive source, the counter reading is 960 counts per minute. The half-life of the source is 20 minutes. What is the counter reading 1 hour later? So the half-life is given, that's 20 minutes. In 1 hour, So 60 divided by 20, and it will be 3 half-lives would have passed. So corrected counts per minute, the reading is 960. From there, you subtract 40. So you get 920 is the reading from the sample. We have subtracted the background. So in 1 hour, there will be 3 half-lives because each half-life is of 20 minutes. So now in 1 hour, 3 half-lives would have passed. So at the start, the count rate is 920. You have the 920, it becomes 460. Again, half it, it becomes 230. Again, half it, it becomes 115. Now the counter, the reading on the counter will be 115 plus the background. Again, add the background. So you will have 155 counts per minute. 155. So I think C is the answer, sir. Question number 36, C is the answer. This is how this is done. First of all, we have subtracted the background, then we have half it, half it, half it, because the 3 half-lives have passed. Half it, then whatever the answer comes, then again half it, whatever the answer comes, again half it. So then again add the background in it. So 155 is the answer, sir. So C is the answer. Question number 36, C is the right answer. Question number 37. He says, which planet in our solar system is nearest to the sun and what is the nature of the planet? Okay. So you know the name of the planets, and the name of the planets are my very educated mother just served us nachos. This is how you remember those names. So the planet nearest to the sun is Mercury. Okay. And Mercury is rocky. So A is the choice. The first four planets, and they are rocky. So I think question number 37, A is the choice, which is right. Okay. Question number 38. He says a space station orbits the Earth at a distance of 7,000 kilometers from the Earth's center. It makes 15 orbits in 24-hour period. So it takes 15 orbits around the Earth. Okay. What is the speed of the space station in its orbit? Okay. What is the speed of the space station in its orbit? Okay. In kilometer per hour, you have 10. So it's going to, it completes 15 revolution orbits around the Earth. And the radius of that orbit is given. So 15 revolutions. Okay, so he's doing 15 revolutions. So here we have question number 38. He says distance divided by time, speed will be 15 revolution. In each revolution, he covers a distance of 2 pi r. So 15 multiply 2 multiply pi multiply radius 700 kilometer. And the time is 24 hours. So it will be 15 multiply 2 multiply pi multiply 7,000 kilometer divided by 24 hours. So it will be 27488 kilometer per hour, and that is approximately 27,000 kilometer per hour. 27,000 kilometer per hour. 27,000 kilometer per hour. So I think D is the option, sir. Question number 38, D is the right option. And this is how this is calculated. Okay, that was question number 38. And this is my very educated mother just served us nacho. This is for the question number 37. This is the Mercury, which is nearest to the sun. So 38D is the right answer, sir. Okay, we are on the question number 39. He says, which nuclear reaction powers a stable star? A stable star, the process of fusion, in which smaller nuclei fuse into each other and make a larger nucleus. So nuclear fusion of the krypton nucleus and a barium nucleus into a uranium nucleus, nuclear fusion of hydrogen nuclei producing helium. This is the right answer. It's a factor in the fusion of the lighter nuclei is happening. Krypton and barium, they are very heavy. Okay. So question number 39, I think D is the right answer, sir. Question number 40, he says, which stage in the life cycle of a star are listed in the order that they occur. Interstellar dust clouds, then a stable star, then a protostar. And here she says protostar, red giant, and stable star. Red giant and white dwarf and protostar. No. Stable star, red giant, and white dwarf. This is the right answer, sir. Let me show you. These are the before we make a choice. So let me show you. This is very important. You see, for a solar mass star, it is a stellar nebula, and then it becomes a protostar. Then it becomes the main sequence star, which means the stable star. Then it becomes the red giant. Then it becomes the planetary nebula, and then it becomes the white dwarf. So red giant, and it's a stable star. Then it becomes a red giant. Then it becomes a white dwarf. This is the option D. Okay. Question number 40D is the answer. Okay. So for a very large star, stellar nebula, then protostar, then main sequence star, which we call the stable star, then it becomes red supergiant star, then supernova happens, then it converts into a neutron star, or it converts into a black hole. So remember these, this is very important. Remember this. So we are done with this paper. So my dear students, and today in this video, we have completed the May-June 2023 2-1 paper. This is Cambridge IGCSE Physics, Extended Physics, its paper. So I have tried my best to explain you the concepts of how the choices have been made here. I have tried to write them. I have tried to explain them. It's possible I'm a human. I might be making some mistake, but to reduce the mistakes, we always check our answers with the marking scheme. If you think that this video is useful, if you think this video is helpful to you, please share the link of this video with your friends, with your teachers, with your class fellows. Also like this video, subscribe to my channel, share the link of this video on your Facebook, on your Twitter account, on your Instagram, on your TikTok, on your Snapchat. You see, when you do this, you help me to promote my channel. And I think it's a great blessing for me that I can make these videos, which can make the life of so many students around the globe little easier. They can make the life of their teachers, their parents, little easier. Thank you very much. Have a good day. And God bless you all.